Scientists have been studying permafrost along the Dalton Highway since the late 70s.
Well, it's one of the oldest projects we are working on, and it started in late 70s, early 80s, and it was developed and implemented by Professor Tom Osterkamp. He now retired or emeritus professor. That time he was a professor in geophysics at the Geophysical Institute. And his idea was very straightforward. There was already some discussion about warming, climate warming, and he decided to establish some number of benchmark boreholes where we can measure temperature in permafrost and see how permafrost reacts to changes in climate.
The boreholes are located in different landscapes and climate zones. Today, we are at Galbraith Lake.
Primarily what we're interested in measuring is the temperature of the ground, the temperature of the permafrost. And so at all of our sites we have one of these probes here. It's a 1 meter long probe stuck into the ground. So that gives us a good record of the temperature over the course of the year.
At some of the borehole locations, they are also measuring the depth of the active layer each year.
Active layer, it's the upper layer of the ground, which is seasonally frozen and seasonally unfrozen. During the summertime it's unfrozen and freeze up during the winter. And active layer thickness is one of the most important index of thermostate of permafrost. When permafrost getting warmer, it getting deeper.
Scientists now have almost 30 years of data measured every year in the same boreholes at the same depth.
Data show that it was expected, show very nicely trends in changes in temperature in relation to changes in air temperature. And also there is another factor, is a snow cover. So we found that temperature was a little bit cooling during the early 80s, but since mid-80s till now, it's generally warming in all boreholes along the Dalton Highway.
Warming and thawing permafrost is not just a concern in permafrost-rich areas. It has global consequences as well.
So the amount of carbon is huge in the permafrost. And when permafrost will start to thaw from the top down, this carbon will be subject of microorganisms decomposition, and eventually it will come to the atmosphere as a carbon dioxide or methane, depending on conditions, and increase those greenhouse gases concentration in the atmosphere. So it's kind of positive feedback. More warming, more thawing of permafrost, more gases released from permafrost into the atmosphere, which increase warming again, increase thawing of permafrost. So it's positive feedback which can have very serious global consequences.
Although much of the permafrost in the world is in remote, isolated areas, it is interconnected with the rest of the world. The activities that people engage in their local communities increase the amount of CO2, which increases the climate warming that has a direct impact on the permafrost.